In Module 2, Lesson 2, we're going to interpret division of a whole number by a fraction, and we will continue to use visual models. In class, we were divided into 5 groups, and each group was given a different question number, and that question number needed to be written down, as well as writing a division question from it and a multiplication question. Then the group was to make a rough draft of a model to represent the question, which was then put on construction paper or directly onto the board, and we were then going to go as a group, travel among these representations and see if we could fill out a chart showing those. So as we traveled to each model, each question needed to be answered. Question 1, how many 1/2 miles are in 12 miles? We would need to take 12 and divide that by 1/2. From the model, we should have also seen that the multiplication question could be 12. So in question 2, how many quarter hours are in 5 hours? We would take 5 and divide it by 1/4, because quarter means 1/4. Think of money if you have trouble with that. And represented out of the multiplication question, we would have 5 times 4. Question 3, how many 1/3 cups are in 9 cups? Again, we'd take the 9 cups and we would divide it by 1/3. Or as a multiplication statement, we could write it as 9 times 3. Number 4, how many 1/8 pizzas are in 4 pizzas? We would take our 4 pizzas and divide it by 1/8. As a multiplication statement, we could say 4 times 8. And then finally in number 5, how many 1/5 are in 7 wholes? We could take 7 and divide it by 1/5, which as a multiplication statement could be 7 times 5. All of the problems in the first example show what is called measurement division. When we know the original amount and the size or measure of one part, we used measurement division to find the number of parts. You can tell when a question is asking for measurement division because it asks how many blank, how many blank are in blank. You can see how many, whatever this is, are in whatever this is. 2 measurements. Let's look at a different example. Molly used 9 cups of flour to bake bread. If this was 3/4 of the total amount of flour she started with, what was the original amount of flour? You should notice that this is not trying to figure out how many 3/4 are in 9. We know that 9 cups is part of the entire amount of flour needed. Instead, we need to determine 3/4 of what number is 9. Thinking back to Module 1, remember, we do not know the whole. We know the part, and we know what fraction that part represents. So we'll start off by drawing a model. Our fraction represents 4 parts, and 3 out of the 4, 3/4 of those parts, are equal to 9 cups. Those 3/4 3/4 equal 9 cups. What we don't know is how much the whole is. That is our question. Thinking back to our tape diagrams, this should look very familiar to you. We have drawn the representation in a tape diagram of 3/4, and then we showed that these 3 parts equal 9. If 3 parts equal 9, inside each box we ought to have 3. 9 divided by 3 equals 3. So we can put inside our tape diagram, or our fraction bar, whatever you want to call it, a 3 in each piece, which means our total amount must have been 3 times 4, or 12, at the beginning. 12 cups was the original amount of flour. We'll explore a little further in the exercises. Looking at exercise 1, a construction company is setting up signs on 4 miles of the road. If the company places a sign every 1/8 of a mile, how many signs will it need? First of all, let's set it up mathematically. We have 4 miles of road, and we're going to divide that road into 1/8 miles, into pieces that are 1/8 of a mile each, and we'll put a sign at each 1/8 of a mile. Remember, dividing equally into equal parts means division. So we're taking 4 and we're dividing it by 1/8. We also know from the previous lesson that we could rewrite this as a multiplication statement as well, which would be 4 times 8. And we would expect the answer to be 32, but we still need to represent it. So when we represent it, we start with one piece and know that that one piece represents 4. But that one piece is only 1 out of 8 pieces, because we know that we are going to take that 4 miles, and every 1/8 of a mile we are going to put a sign. So we would need to have 8 pieces altogether in our representation. From our model, we can see that if we have 8 pieces and each piece represents 4, 4 times 8 would be 32. In exercise 2, George bought 12 pizzas for a birthday party. If each person will eat 3/8 of a pizza, how many people can George feed with 12 pizzas? So to represent that as a division problem, we would need to take 12 pizzas and divide it by 3/8, which is how much each person will eat. 12 divided by 3/8. And then to represent that with a fraction bar or tape diagram, whatever we want to call it, we would need to take our bar and first of all divide it into eighths. Then we'll shade 3 of the eighths to show that this is the portion we'll be talking about. We could do the same thing by using a brace or a bracket like we did before. And we know that the piece that we're talking about is 12. So when we look at the tape diagram or the fraction bar, we can see that there are 3 pieces going into the 12 that represents. 12 divided by 3 would be 4 inside each piece. Continuing on with that pattern, we would have 8 at this point, 12, and so on. And since there are 8 pieces altogether and each piece represents 4, we would have 4 times 8, or 32, which would be the number of people that could be fed with those 12 pizzas. Mathematically, if we wanted to write this as a multiplication problem, we could write 12 times the reciprocal of 3/8, which is 8/3, 8 over 3. When you're multiplying fractions, both numbers have to be fractions. So to take the whole number 12, we would turn it into a fraction by putting 1 in the denominator. We have 12 whole pizzas, or 12 ones, which if we then multiply by 8/3, we would multiply the numerators, 12 times 8, which is 96, and then we would multiply the denominators, 1 times 3, which is 3. Then we would need to simplify our improper fraction, 96/3. When you do the division, 96 divided by 3, you would get 32 over 1, which is the same as 32. So 32 people will be able to eat. In question 3, the Lopez family has adopted 6 miles of trail on the Erie Canal. If each family member cleans up 3/4 of a mile, how many family members will be needed to clean the adopted section? By now, you should be able to set these division problems up pretty easily. There is a stretch of the Erie Canal that is 6 miles long, and each family member can clean up 3/4 of a mile of that section. So we're going to write the division problem 6 divided by 3/4. We'll show it mathematically as following the division rules first, and then we'll model it. 6 divided by 3/4 can be changed to the multiplication equation as 6 over 1, which is just taking the whole number 6 and putting it over 1. That's how we make it into a fraction. Times the reciprocal of 3/4, which means you take that fraction and you flip it 4/3. Then we'll multiply the numerators, 6 times 4, which is 24, and the denominators, 1 times 3, which is 3, and then simplify that final answer. 24 divided by 3 is 8. So we expect to need 8 family members when we draw the model. In showing our representation, we know that 3/4 is related to 6. So we would take this whole piece, and we know at this point that that is equal to 6. There are 3 pieces in this diagram that represent 6. So 6 divided by 3 would be 2 in each piece. From this point, then, we can see that we would need 8 family members. So our model proves our math. Exercise 4. Margot is freezing 8 cups of strawberries. If this is 2/3 of the total strawberries that were picked, how many cups of strawberries did Margot pick? Notice the pronoun this is pointing to the 8 cups of strawberries. 8 cups of strawberries is 2/3 of the total strawberries. If you're still struggling, circle some words like 8 cups of strawberries and draw an arrow pointing to what the 8 cups of strawberries are. 8 cups of strawberries is 2/3 of the total strawberries that were picked. So we'll set it up mathematically. Mathematically, we would have 8 divided by 2/3, which rewritten as a multiplication statement would be 8 over 1 times the reciprocal of 2/3, which is 3/2. Multiplying our numerators, 8 times 3 is 24. Multiplying our denominators, 1 times 2 equals 2. And simplifying our final answer, 24 divided by 2 is 12. So we expect that Margot picked 12 cups of strawberries. Now we'll represent it with a model to prove. So we drew a model of the 2/3. We shaded 2 of the 3 pieces. And those 2 pieces represent 8 cups. So we know then that this represents 8. And if 2 pieces represent 8, 8 divided by 2 must be 4 in each piece. 4 times 3 is 12. So our math is correct, proven by the model. In our final exercise, Regina is chopping up wood. She's chopped 10 logs so far. And if the 10 logs represent 5/8 of all the logs that need to be chopped, how many logs need to be chopped in all? Our division statement would be 10 divided by 5/8. Mathematically, 10 divided by 5/8, rewritten as a multiplication equation, would be 10 over 1, which is 10 represented as a fraction, times the reciprocal of 5/8, which is 8/5. Then we multiply the numerators, 10 times 8, which is 80, and the denominators, 1 times 5, which is 5, and simplify our final answer, 80 divided by 5, which is 16. Next, we'll draw a model. So we can see our model is cut into 8ths. That's the size piece we need. And 5 of them have been shaded in to represent the 5/8. These 5/8 stand for 10. And if we have 10, which is being represented by 5 pieces, 10 divided by 5 would mean that each piece represents 2. So we know that the whole would be 2 times 8, which is 16. Our model has proven our math.